class, there are 25 students that have a dog, 16 that have a cat, and 10 that have both. There are 8 students who do not have a pet. They don't have a dog or a cat. Draw a Venn diagram for this information, and then we'll go through and look at probabilities. So when we draw the Venn diagram, one thing that we need to do is go ahead and identify what we are working with in each set. So we're going to look at dogs, and then we're going to look at cats over in this other circle. Right, remember, anytime we try and do a Venn diagram, we want to start here in the middle, and that would be the ones that have both dog and cat. And if we come up here to the top, notice we have 10 that have both. So I'm going to put 10 here in the middle. And then backing up to 16 have a cat. Now remember, within the cat circle, we can only have 16. I already have 10 in the middle, so that leaves 6 on the right side of the cat circle. So that way there's 16 all together in the cat circle. In the dog, we have 25 students that have a dog. Again, we're only allowed to have 25 in the dog, so that leaves 15. So that we add the 15 and 10, we get 25 for the dog. And then we have one other piece given to us. There are 8 students who do not have a pet. Those 8 would go outside. They don't have a dog or a cat. All right, in order to continue moving forward with probability, we need to know our total. How many students are there? Well, we have 15 and 10 and 6 and 8. And if you go add that by hand or grab a calculator, you can add that, and that ends up being 39 students. For part A, what's the probability that we pick a student that has a dog? Well, out of the 39, how many are in the dog circle? We have 15 and 10, which is 25. If possible, simplify. If that one doesn't, we leave it. Next one, probability that we pick a student that has only a dog. Only a dog means that they don't have a cat, so that puts us in the kind of in this left part of the dog circle here. Those 15 have a dog, but not in the cat. So that would be 15 out of the 39. Again, check to see if it simplifies. This one doesn't. What's the probability that we have a dog and a cat? So that would be the 10 in the middle that have both dog and cat. Out of the 39 students, again, doesn't simplify. We're going to look good. What's the probability they have a dog or a cat? So dog or cat means we have to pick up everything in the dog-cat circle. We need to consider the 15 that have dog only, the 11 that have dog and cat, and the 6 that have cat only. Adding those possibilities of dog or cat up, we get 31. And so the related probability would be 31 out of 39. Last question related to this problem. What's the probability that we have neither a cat nor a dog? That is the 8 out of 39. All right, continuing to our next example. In an organization with 73 workers, there are 50 workers that are proficient with presentations, 35 proficient with computers, and 20 that are proficient at both. Draw a Venn diagram for this information, and then we will go answer the probability questions. All right, so we are dealing with proficient at presentations and at the computer. Omni is for presentation, C for computer there. All right, remember, we always want to start here in the middle in the overlap area. In this particular case, we are given the information that 20 are proficient at both. So I'm going to put 20 in the middle. And then just working my way back, we have 35 that are proficient with computers. So within the computer circle, we can have 35. We already have 20, so that leaves 15, so that together the 20 and 15 make 35 proficient at computers. We were also told that there are 75 that are proficient with presentation. We already have 20 in the presentation circle, so that leaves 30. Adding the 30 and 20, we get 50 proficient with presentations. All right. But if you'll notice on our Venn diagram, there is one section we haven't filled in yet. How many are not proficient with presentations nor with computers? Well, to find that, we need to add up what we do have. Right now, we have 30 and 20 and 15. And 30 and 20 and 15 adds up to 65. But we have 73 workers, so 73 minus the 65 that we already have recorded leaves 8 on the outside. All right, so that means we have 8 workers that are not proficient at presentations nor at computers. All right, so going to our probability, what is the probability that the person that we select at random is proficient with presentations? Well, out of the 73 workers, we have how many in the presentation circle there? We've got 30 and 20, so that gives us 50 of the 73. Proficient with presentations or computers. So we have to bring up all of the proficient with presentations, that's 30 and 20, and the other 15 that are also proficient with computers. Picking all of those up, we get a total of 65 workers. And so the probability that they're proficient with presentations or computers is 65 out of the 73. Proficient with presentations and computers, there's only 20 of those in the overlap that were proficient at both. Is proficient with neither presentations nor computers, that's referring to the 8 that are not proficient with either presentations or computers. Proficient with only computers and not presentations. So they are in the computer circle, but not in the overlap. That would be these 15 over here, kind of on the right side that I just highlighted, that are in computers, but not in the overlap of the presentations. All right, and that is 15 out of 73. Last question for this Venn diagram is proficient with only presentations and not computers. So they're proficient with only presentations, not computers. That would be highlighting these 30 on the left that are in the presentation, but not in the computers. Last thing I'm going to introduce in this video is an idea of empirical probability. Empirical probability estimates probabilities from experience and observation. All right. So empirical probability estimates probabilities from experience and observation. Theoretical probability is based on assumptions about the probability of an event, while empirical probability is based on data of what has actually transpired. So all things we've done before have been based on actually, rolling a 6-sided die, you have one number of 6 possibilities. But empirical is based off of data. So for example, as we get into example 11, we're going to look at 3,500 claims of an insurance company. 1,200 were for more than 5,000. So we're going to look at this idea of splitting up some claims and how much they were worth. And this would vary depending on which group of claims you were looking at. So this is called empirical probability because it may change based on the previous data that we are looking at for the problem. In this case, we have 3,500 claims for theft. An insurance company notices that 1,200 were for more than 5,000. Part A, what is the empirical probability that the next claim will be more than 5,000? Well, out of our 3,500 claims, how many were for more than 5,000? That's at 1,200. So 1,200 out of the 3,500 were for more than 5,000. Now we could go ahead and simplify that. That would be 12 out of 35. If you wanted to then take it to a decimal just to kind of have maybe a number that would make a little bit more sense to us as we're talking about it, if you put 12 divided by 35 in your calculator, it becomes 0.343 if we round it. And so that would then turn into 34.3% approximately. Again, I did have to round that. So about 34% are for claims of more than 5,000. All right. Part B, what is the related probability to it that the next claim will be for less than 5,000? Well, of our 3,500 claims, 1,200 were for more than 5,000. So that means the difference has to be for less than 5,000. All right, so 2,300 out of the 3,500, the remaining ones were for less than 5,000. Reduce, that's 23 out of 35. And then again, if you wanted to divide it and turn it into a decimal, 0.6 0.57, again, rounded approximately, or 65.7% roughly. All right, so a little bit there working with empirical probability.